Apparatus.
British pendulum tester is the apparatus used in this test. This is the main part of the British pendulum tester.
Procedure.
Pendulum have been released and make sure it touch the ground. We must take the reading from the apparatus and record it. This process must be repeated at two locations and two different conditions, wet and dry.
Results and discussion.
Table on the left side show the result we obtained from the test. Discussion for skid resistance test. All location recorded higher BPN values in dry conditions compared to wet conditions because water reduced the friction between the tire and pavement surface. Location A show the highest skid resistance with an average BPN of 130 for dry and 140.7 for wet, indicating an excellent and safe pavement condition. Location C also demonstrated good skid resistance, recording 112.7 for dry and 86 for wet, which indicate adequate friction under both conditions. Location B recorded the lowest wet BPN values of 31.1, representing a significant reduction in skid resistance and a higher risk of skidding during wet weather. According to JKR guidelines and international standards ASTM E303 and BSTN 13036-4, BPN higher 55, which is good to excellent skid resistance, and BPN lower 35 is poor and potentially hazardous pavement condition. Therefore, location A and C are considered safe, while location B may require maintenance or surface treatment to improve road safety, especially during rainy conditions.
Apparatus.
The apparatus used for these experiments are brush, ruler, sand, cylinder, and sand spreader.
Procedure.
The test surface was cleaned and dried before testing. A 20 ml of sand was poured onto the pavement surface. The sand was spread evenly in circular motion until surface voids are filled. The diameter of sand patch was measured.
Results and discussion.
Now I will explain the result for the surface texture test. This test was carried out at 3 different locations. The centimeter was measured to compare the surface texture of each location. For location 1, the average centimeter is 10.13 cm. This shows that the surface has a moderate texture and is slightly rough. For location 2, the average centimeter is 10.3 cm. This result is almost the same as location 1, meaning the surface texture is also moderate and consistent. For location 3, the average centimeter is 14.78 cm, which is the highest value. This means the sand spread wider on the surface. Therefore, location 3 has a smooth surface compared to location 1 and location 2. Overall, location 3 has the smoothest surface, while location 1 and 2 have rougher surface. This shows that the smoother the surface, the larger the centimeter will be.
Apparatus.
The apparatus used for this test are the surface drainage test apparatus, a 400 ml measuring cylinder, a stopwatch.
Procedure.
First, 400 ml of water is measured using the measuring cylinder. Then, the apparatus is then placed at the selected test location, which is location 1. Next, The valve is open to allow the water to flow onto the pavement surface, and at the same time, the stopwatch is started. Stopwatch is stopped once all the water has completely drained from the apparatus.
Results and discussion.
Now I will explain the results of the surface drainage test. We carried out the test at the 3 different locations, and each location was tested 3 times. For location 1, the average time was 8.15 seconds. This is the highest time, which means the water flow more slowly. This may be because the drain has a gentle slope or small blockage. For location 2, the average time was 7.85 seconds. The water flow faster than at location 1, so the drainage performance is better. For location 3, the average time was 7.52 seconds, which is the lowest time. This means the water flow the fastest, showing that this location has the best drainage performance. This may be because the drain is cleaner and has a better slope. Overall, location 3 has the best drainage performance, followed by location 2, while location 1 has the slowest drainage. The results show that the condition of the drain, such as its slope and cleanliness, can affect how fast water flows.